How can you identify deadlocks with no error messages? Imagine a busy intersection where cars are waiting for each other to move, but no one ever does. That's similar to what happens in a deadlock in a computer system. Deadlocks happen when two or more threads or processes are stuck waiting for resources held by each other, and nothing moves forward. The tricky part is, sometimes there are no error messages to tell you what's wrong. So how do you find out if a deadlock is happening? First, look for signs like the system or application freezing or becoming unresponsive. If the program stops responding and nothing seems to work, it could be a deadlock. Next, check the threads or processes using monitoring tools. These tools can show you which threads are waiting and which are holding resources. If you see threads stuck in waiting states, that's a big clue. Another way is to observe resource contention patterns. Using debugging or profiling tools, you can see if threads are holding locks while waiting for others. If you notice a circular wait, where thread A waits for a resource held by thread B, and thread B waits for a resource held by thread A, that's a deadlock. You can also analyze the system's resource usage. If certain threads stay blocked for a long time, it indicates a potential deadlock. Creating lock graphs can help visualize how resources are acquired. If these graphs show cycles, that's a deadlock warning sign. Setting timeouts on lock operations or transactions can also help. When a thread waits too long and then times out, it suggests a deadlock might be present. Although this doesn't directly detect deadlocks, it helps reveal them by forcing the system to break the cycle. In environments like databases or operating systems, deadlock detection mechanisms are often built in. They periodically check for deadlocks and resolve them by aborting one of the involved processes. But if these checks are disabled or slow, deadlocks can silently stall your system without any error message. From a debugging perspective, understanding the order in which locks are acquired is key. Ensuring a consistent locking hierarchy can prevent deadlocks from happening in the first place. Using tools that detect lock order violations or potential deadlocks before they cause issues is also very helpful. Regularly profiling and monitoring your multi-threaded applications can catch unexpected blocking patterns early. Combining these methods, monitoring, logging, analyzing thread states, and resource locks, allows you to identify deadlocks even when no error messages appear. This way, you can pinpoint the root cause and fix it before it causes major problems.